Hi friends, welcome to follow up. Let's have a look at problem 516 again, longest palindromic subsequence. In the previous video, we explained two formats of solutions. The first one is based on dynamic programming, in which we use a DP table and then do the DP update rule. And in the second solution format, we used the find method and our find method for a string to construct the palindromic subsequences and then retrieve the length. So in this video, we're going to continue look at the DP solution. And here the purpose is to demonstrate how to use cache in the coding. So here, let me make some annotation. So it's the revisit of problem 516, right? So here the goal is to explain how to use cache. First, let's have a look at the problem statement, which is very short. So we are given a string s. We want to find the longest palindromic subsequence, the length in s. So here we want to find the length. Actually, we can also retrieve the corresponding subsequence if we like. So here, a subsequence is to distinguish with a substring, right? So this is the second paragraph. We are not going to read through. And we have two examples here. And in the first one, so the output is 4. So we can consider the 4 b's, right? In the second example, we can consider the middle 2 b's. The output is 2. And the constraints for this problem are the following. First, s is not empty and its length is bounded above by 1000. And secondly, s consists only of lowercase English letters. In the previous video, we explained how we take advantage of the second constraint or assumption, right? So we can construct by iterating all the possible 26 lowercase English letters. And in this video, we're going to explain how to use cache. So here we're going to first write a solution in a recursive format, essentially DP, but with cache. And in the second format, we're going to use a dictionary to demystify the caching part. So now let's first focus on the first solution, that is a DP solution. So we're going to, for this, we're going to write a function that do the job, right? So here, let's first track the length of this s. So here, basically, we're not going to consider the s reverse. So basically, we want to define the function, let's see, utility function, so to get the length of the longest palindromic string for the substring, let's say s starting from L up to right. So essentially, it's a construction or check procedure. So let me first write the function definition. So let's call this function f. So it accepts two indices, L and R, right? So the goal is to find the length of the longest palindromic substring length from S, so starting from L, then ending at SR. So for this, again, let's first write some stop condition, because we are going to write this function in a recursive format. So first, if L is larger than R, so in this case, we regard it as a base case, we're going to return 0. Another one is if L equals R. In other words, we are concentrating on a single character. Itself is a palindrome subsequence. So in this case, we are going to return 1, right? So otherwise, so let's check if the character at index L and at index R are the same or not. So basically, if SL equals SR, right? So in this case, so we should consider this. So we should consider the length of L plus 1 moving to the right by 1 index, then R minus 1, right? Then plus 2. So the 2 corresponds to the two same characters at index L and index R. So that's the one case. Another case is that so the two characters at indices L and R are different. So in this case, we want to return the max of f. So starting from L and ending at R minus 1. The reason is that the SR does not equal to SL. Or this one, right? We can also examine this L plus 1 up to R, right? So finally, let's see. This will be the recursive or utility function. So because we are actually make some computations or repetitions, so we can use cache to record the possible to avoid possible repetitions. So this way we finished the utility function, and next we just need to do function call and return. So for this we just need to return f. So we want to examine the full string s. So we can from index 0 then ending at n minus 1. So this forms a solution format. So here I'm using the cache as a decorator, right? So let's first check it and then move forward. Yeah, it passes the second example. Now let's look at the generic case. Yeah, it passes all the test cases. So this is one format of using cache. So if you are not very familiar with this decorator things, so we can actually write another format. Let's copy this function signature and make this one version we want. So now let's look at another solution format. So essentially the same code. However, we can do the thing a little bit different. So actually we can also copy this part. So here we get this length, right? And then we want to compute the utility function to get this length for the corresponding substring. So here let me delete this decorator. So I'm going to use a dictionary to do the thing. Essentially this is the essence, right? So we do this, and then when we do this function, let's first either we combine the stop condition and the dictionary check, right? So first let's see if we have some cache hit, right? So we want to check if L and R is in the memo in the dictionary. If so, we just need to return memo the corresponding value, right? So this is the one. And then the stop condition, we do not change this one, or we do not change this one either. So in this case, here let's first not do the return. What we are going to do is to set memo LR equals memo. So let's see, L plus 1, R minus 1, and plus 2, right? So this is the format change. Otherwise, so what we are going to do, we do memo LR equals the max of f L R minus 1 and f L plus 1 L plus 1 R, right? And then finally, what we are going to do is to return the memo at this key LR. So this way, we didn't explicitly use the decorator, and then we used set asset and dictionary to do the caching thing. So now the second step is still call this function and the same thing. So now let's first do a check. So keep error. So L, let's see, if here L greater than R, we return 0, and L equals R. So now let's check this one, L plus 1, R minus 1. And then let's see this one, L, R minus 1. Then yeah, this should be okay. Now let's check. this one. Oh, here, I guess this is the part that we should change. So we should change this to be fl plus 1 or minus 1, because that I will need to first compute, then store. So now let's check. Yeah, it passes the second example, I guess. Now let's also examine the first one. So we should have 4 returned, right? Yeah. So now let's look at the generic case. Yeah, it passes all the cases, but it looks sort of slower. In general, it should be the same. With that said, that's about it for this video. So here we explained DP solution in recursive format. So here in the two solution formats, essentially they are the same solution. And in the first format, we use specifically the cache or the decorator thing. And in the second one, so we used a set asset dictionary to do the caching. So this actually provides the typical 2 ways of using cache to accelerate or to avoid repetition in using recursion. With that said, I guess that's about it for this video. Thank you.